Welcome to episode 5 of this introduction to Unreal Engine and C++. So far we cover how to install Unreal, set up Visual Studio, explore basic coding, and walk through the structure of the header file for the first-person blueprint class. Now it's time to dive into the implementation file, the CPP, and understand what it's really doing. Line by line, in this video you will learn how the constructor works and how it links code to blueprint, how to configure the capsule, camera attachment, and mesh, how to wire up a player input using the enhanced input system, what a game mode is and why it matters in your project, and finally, how the move and look functions brings your character to life. If this video helps you level up, please support this channel by hitting the like, clicking subscribe, and don't forget to ring the bell so you never miss a new tutorial. These small actions make a big difference and help us keep creating free content to support your journey into game development. Want to go further? Watch the free training, How to Become a Game Changer Video Game Creator After Your Daily Job at Woolun.com. It is designed to help you build a consistent game dev routine and unlock new career opportunities, even with a full-time job. And if you're serious about growing your career in the video game industry, I invite you to learn more about the Game Creator Accelerator and book a time to chat with me. All details are at Woolun.com, link in the description. Now, let's continue. We are back with our project MyShooter FPS, and remember that we were analyzing this class inside C++ class MyShooter FPS. So double click to open it, and we are back on C++ and Visual Studio. In the previous section, we analyzed the MyShooter FPS character H, and now we're going to start with the implementation file or the CPP. The first section is what we call the includes. And the include are directives that is a directive that is used to bring declarations and definitions from other files that mostly are the header files, as you can see here, with an H. And they are associated with classes or functions that you are about to use in this CPP file. The first one and most important is the class associated with the header file that we presented as in the previous section. Look that the first include is MyShooter FPS character .h, because we are going to use these declarations we did here. Then we have the define log category. Remember that in the header file we have the declare log category extern. These two are related, two parts of the same system for enabling custom login categories in Unreal Engine using the UE-log macro. And that macro is the basic tool that you will use for debugging. The next section is the constructor. Keep in mind that in MyShooter header, we defined this function, which is called the MyShooter FPS character. And the function has the same exact name as the class. In the implementation file, what we do is the implementation of that function. And because it has the same name as the class, this is what we call the constructor. When we call the constructor, we are establishing the setup of this instance of a class. The first thing we establish is a CapsuleComponent. And look that we have an initialization with some parameters. If you move the mouse over the init capsule, you can see the parameters, which are radius and half of height. To see the result of this line of code, go to the project, to the Unreal project, and in the first person you have the blueprints, and you have the VP first person, and this is the blueprint that was created based on the class. With the class setting based on the class MyShooter FPS character, which is the class that we have here. And the first component that you see is the capsule. This is the capsule that we attach or that we add using the constructor and passing these two parameters. In other words, we are creating the different components for this blueprint controlled by C++, not adding them directly here as a component on the blueprint. If you wish to work exclusively with Blueprint, then you can also add the component and simply look for a capsule and then select the capsule collision. The next group of lines, what they do is to create a new camera component and attach it to the character. You see this camera on this position. This is the component that we are adding with this group of lines. Create a default subobject is a function Unreal uses to safely create and manage components in C++. The first-person camera is just an internal name given to this camera, and of course that is useful for debugging or a blueprint reference. Back in the blueprint, you can see the camera, the first-person camera component, and the name that we assigned for it. In simple words, what this line of code says to Unreal is add a camera to my character and call it first-person camera. Continuing, we have the setup attachment. And what this line does is attaches the camera to the get capsule component, the one that we set on the 22nd, which is the main root collision of the character. Think of this line like you are saying to Unreal, mount this camera on the character's body so it moves with them. With the set relative location, we're moving the camera to a specific position relative to the capsule, because we said that this component, the camera, will be attached to the capsule component. So the location will be relative to, let's say, the parent component. With these coordinates, we are telling Unreal, place the camera behind and a bit above the character's head. This is the behind, the -10, and the 60 is a little bit above. And the last line for this group allows the camera to rotate based on the player's input, like turning with a mouse. Remember that this is a first-person shooter game. In other words, what this line of code is saying to Unreal is make sure the camera follows the direction the player is looking. If we go back to the blueprint, you can see that the camera is a child of the capsule component. Close the capsule component and you close as well the first-person camera. And if you click the camera, you can also see in the details the, for example, location of the camera. Remember that we set it to -10, 0, 60. This was the same coordinates that we specifically defined with C++. Looking at these parameters, you can see the marriage that we have between C++ and blueprints. Only that here we are controlling all the parameters that you can establish inside blueprints on the details for every component. Let's continue with the next block of lines of code inside the constructor. The next group create a mesh component that will be used when being viewed from the first person view. Well, basically is the arms that you will see here on the blueprint. The first line is the definition of the skeletal mesh component, which is used to show an animated model like the arms that we are presenting here, and it names it character mesh 1P. In other words, this is telling to Unreal add a 3D model to represent the characters from a first person point of view. Then we have the set only owners C, and what it does is saying that this mesh will only be visible to the player who is controlling the character, the owner. Then we set up the attachment to what this component will be attached to. In this case, we are going to attach it to the first-person camera. So this component will be a child of the first-person camera component, who at the same time is a child of the get capsule component. Back in the blueprint, you can see that here is the mesh 1P, which is a child of the component first-person camera component. Then we have these two lines of codes, and what they do is that they disable shadow casting for this mesh. Since this is a mesh with just two arms, will be very weird to casting a shadow from these two arms. So in this case, Unreal, what it suggests is do not cast any shadow. The next slide is commented, but what it does, what it should do is change the rotation of the mesh relative to the camera, but right now it's not doing anything. And finally, we set the relative location of this mesh. Keep in mind that this relative location will be based on the component where they were attached to. In the case of the Mesh 1P, it is the first person camera component. To check all the settings that you place here, you can always go to the blueprint and click on the component, in this case the Mesh 1, character Mesh 1P, and see the details. Taking a quick pause here, if you're finding value in this breakdown of Unreal C++ code, imagine what consistent practice and the right strategy could do for your game dev career. That's exactly why I created the Game Creator Accelerator, to help you build real projects, grow your presence, and transition into the industry step by step. You can also watch my free training, How to Become a Game Changer Video Game Creator After Your Daily Job, at woolun.com. It is a great next step if you're serious about making progress. Now, let's get back to the code. The next function we're going to implement is the begin play. Back to my shooter FPS character, you have the virtual void begin play. And remember, this was a protected function, which means that we are going to override the code of a begin play corresponding to the parent class. But what we usually do when we are talking about classes that will override the code of the parent class is that we want first to execute the code that is in the parent class, and then we do something else. That's why in the implementation, we're overriding the code, but the first thing we do is called the super begin play. That is telling C++, please, before anything, execute the code that it is by default in the superclass or in the parent class. And then if we want to implement some extra code, we'll do it after this call, after the super begin play. The next implemented function is the shooter FPS character setup player input component that you can see here on this protected section. The setup player input component is called by the engine automatically, specifically by the A player controller when a pawn or character is possessed by a player. Possessed meaning that the player took control of that character. With this function, the engine tries to identify what is the input component that they will use to control that character that you possessed. This is why we pass this parameter, which is the player input component. Back for a moment in Unreal to explain this a little bit further, go to the world settings, and inside the world settings, look for this section called Selected Game Mode. A game mode is like the rule book for your game. It tells Unreal who the player is, what kind of controller they use, what happens when the game starts or ends, and what actors are used for spawning, scoring, or managing the game flow. In plain words, the game mode is the brain that controls how your game behaves, and it decides how the game is played, who plays it, and what happens when they do. Different game modes in one game, for example, if you're going to take control of different types of characters. Let's say that the controllers for different type of characters are different. If you are playing with your first-person character, should be different if you are playing with a car or if you are playing with a bird. For the FPS project, you have inside the world settings the specifications in selected game modes for the default pawn class, HUD, players controllers, and so on. In the player controllers, if you click here, you can identify the BP first-person player, and inside you have the input mapping context. Going to the input mapping context, which is in first-person input, here it is, input mapping context C, you can see the controls for the jump, the move, and the look. If you want to check more details about this, about the input system, I have a tutorial which is called Intro to Enhance Input System to Control Animations, where we go in detail. I will leave the link inside the description. Now let's go back to the blueprint and to our code. Inside the function, the first thing we do is to get the enhance input component from the player input component. We do it by using a cast function, and the type of thing or the type of component that we are looking for. In this case, the uEnhance input component. And we are looking for this component inside the player input component, which is this parameter. If this is false, we're just going to fail and present this message. This is the UIE log, the line for presenting an error message. If on the other side is true, then we use the enhance input component to bind an action, in this case, several actions like jumping, moving, and looking, to the functions that we have here for move and look, and for the jump action that is predefined in Unreal. The way to bind an action with a function like move or look, let's start with this one first, is enhancing input component, the one that we set here, bind action, move action to e trigger. In this case will be a trigger because the move is that you are going to continuously checking the move as you use the joystick of your gamepad or the keys that you keep pressing. Then the parameter this, and what inside the my shooter FPS character you are going to call, what function you're going to call. In our case, move, which is on the bottom. The question that you might have at this moment is why we are sending these parameters as a reference instead of a pointer. Because when we use the reference, we're telling here's the address of the function inside this class that I want you to call when the input is triggered. If we decided to use an asterisk for a pointer, we will tell him try to use what's at that location. That in this case doesn't make sense because we want just to use this function when the action happens. In simple words, you pass this parameter because Unreal needs a reference to the function, not the function's result, and not something to dereference. This is how C++ tells the engine, call this function when the input, this input is happening. By the way, remember that we define these inputs inside the header. Here are the input actions: jump, move, a bit lower, the look action. The functions jump and stop jumping are already implemented in the base class A character. Remember that we have our base class is A character, and because we are a children class, we don't need to implement it. And these functions do what you need them to do to initiate the jump and to stop the jump. The ones that are important at this moment for us are the move and look. So let's start with the move. When we set the actions on the header, let's go to the move action. We decided that this is going to be an edit anywhere, blueprint read only, category input, and well, the rest of the parameters that you already know. If we go to the BP first person character, we can look in the details for the input. And here you have the input actions that are associated with these actions. Let's go to the let's go to the action move. Click here. And you must have defined an action for this one. Let's open the action. Inside the action, you have a value type, which is an axis 2D. This makes sense because even though you are in a 3D world, when you are moving, you're moving over a plane. And a plane has only two axis. That's why the movement, we define it, the movement in front, back, left or right, we define it in just 2D. The easiest way to understand this is take the joystick of your gamepad and see in what directions you can move the joystick. Well, you can move it left, right, front, or back. That's why we're talking about the 2D axis for the move. Close the move. Back to our code and inside the implementation. Because the way we defined the input action, we know that this value that we are passing has a component of the type vector 2D. And this is what we call the movement vector. Look that we define it as of the type f vector 2D. A similar principle applies when we are talking about the look. If you're using a gamepad in a first-person character, you use the other joystick to look up, down, left, or right. But the game is a 2D movement. And if you get to the VP first-person character and look for the look and open the input action, you see that it's also of the type axis 2D. Inside both of functions, then you have this if controller. And you might ask yourself, where is this control declared? Because I don't have it here, neither I have it on the header. The variable controller is declared in the aPawn class, which is a base class for all player controllable actors in Unreal Engine. And remember that our class inherits from the A character, which in turn inherits from the aPawn, which in turn inherits from the A actor. Now, what is controller? Controller is a pointer to the A controller or the A player controller that is currently possessing or controlling the pawn. In other words, it represents the player or AI that is giving input to this character. Once we are sure that we have the controller, then we just defined the movement for Y and for X. In the case of movement vector in Y, we're talking about the moving forward or moving backwards. And in the case of the movement vector in X, we have the get actor right vector, and if we're moving in the opposite direction, then will be the left. The required parameters for add movement input are the get actor forward vector and the direction, and get actor right vector, and of course also the direction. And when we get into the details of the look, you have another function which is add controller yaw input, which will be controlled by the look axis vector X, and the add controller pitch input, which will, where we use the parameter look axis vector Y. This will allow us to take control of, let's say, the camera and looking up, down, left, and right. That wraps up today's deep dive into the implementation file of the first-person character in Unreal Engine. In the next episode, we'll continue analyzing the other key classes that come with the first-person template, so you can understand exactly how all these pieces fit together behind the scenes. If you found this helpful, please support this channel by hitting like, clicking subscribe, and ringing the bell so you don't miss the next breakdown. Got any questions, something to add, or something you'd like to see covered next? Leave a comment below. I read them all, and I love to hear from you. And remember, if you're ready to build a real career in games, even after hours, watch the free training How to Become a Game Changer Video Game Creator at Woolun.com and learn more about the Game Creator Accelerator to get direct mentorship and clear roadmap. Link in the description. Until next time, keep creating, keep sharing, and keep dreaming big. I'll see you soon, my fellow creators.